Darren Marchant with American Nomad News reporting. Orbital debris. Orbital debris are objects in orbit around the Earth, largely man-made objects that are no longer useful and no longer under control. This can be anything from a paint fleck to a Russian glove, an old camera, broken pieces of satellites, nuts, bolts, washers. There's a lot of stuff out there. And fortunately, there's just enough room in between these objects that so far we've had fairly few negative interactions. But it's easily understandable that objects moving as fast as a satellite moves, which are not under control and are small, especially items under 10 centimeters, can be quite a hazard. At over 10 or 11,000 miles an hour or even faster, these objects pose a significant risk. And they've built up over time. There was even a Russian satellite and American satellite that impacted each other over the North Pole. And the result of this were clouds of smaller objects that spread out. One of the things that NASA has come to recognize is something, and I forget the gentleman who is named for this phenomenon, but basically at some point you start getting more and more impacts that come from pieces of previous impacts. And it exponentially blows out of control. Imagine something like when you have a microphone too close to a speaker and you get that feedback effect where an incredibly small amount of time that it takes, the delay for a sound that enters the microphone to go through the amplifier and come back out the speaker is enough to create this overlapping sound that winds up to a very high pitch and loudness. And this is something like the problem that a lot of people in the sphere of talking about space are concerned about, is that at some point it may become incredibly dangerous and difficult to do anything at all in low Earth orbit. This is a big problem. In a paper that I read that came right from the NASA website, and I'm sorry I don't have access to it at the moment, or I would put it in there, they state that there are different classes of debris, and they have plans to deorbit like dead satellites and so forth. When it comes to items that are 10 centimeters and smaller, they don't have an answer. They can barely see the stuff with the radar dishes from the ground. And with more and more of this stuff, it gets harder and harder to identify one object from another and determine its full orbit and all these kinds of things. And they, those orbits decay and they change. So how do we deal with orbital debris? Well, there's some problems. One, overall, all the industry types talk about deorbiting. And there's some problems with deorbiting. One, some of these objects make it all the way to the ground, all the way through the air column, all the way down. And that means that airplanes can get hit, people can get hit, buildings and properties can be damaged. And plus, something I'm interested in is if you have a pound of aluminum, let's say a machinist makes a cube of aluminum that is exactly 1 pound. And for whatever reason, he sticks this thing on a rocket and the money is spent for the fuel and all the sundry other expenses to get this block, this 1 pound aluminum block, into space. The cost of that launch is attached to that aluminum. That's, no matter what you do to get another pound of aluminum up there, you're going to have to pay for the fuel and for the logistics to get that to happen. Well, I have a proposal that takes these things into account. What if in the future we build an infrastructure that prepares us for asteroid mining, prepares us to deal with implications deeper into the solar environment by cleaning up orbital debris with recovery and not deorbiting. What do I mean by recovery in opposition to deorbiting? Deorbiting is fairly clearly understood. It means you take an object that's in orbit and you send it back to Earth, let it burn up in the atmosphere, or hit something on the way down, like the Earth, or a building, or a person, or a plane. And by recovery, what I mean is you capture that object, right? You capture that object, and instead of deorbiting it, you take it to a facility on orbit that recovers its value, that recycles or refurbishes that satellite into either fixing it up, refueling it, or disassembling it, melting down the metal, recovering the aluminum, the gold, whatever, and turning that into new equipment. Then you have a satellite that's built in orbit that you did not have to pay the fuel to take it to orbit. A lot of that energy that's required to process that can be done with solar panels. Solar panels shipped up from the moon can be far less logistically expensive than what is shipped up from Earth. This material could actually be dropped to the moon and reprocessed there on the surface of the moon. Satellites that are made brand new out of recycled material, you can take, aluminum is very recyclable. In even a modest centrifugal station, it would be possible to smelt down aluminum into blocks or rods, sheet, and so forth, and to machine that into components for new satellites. And even if the infrastructure took a long time for more intricate components to be built in orbit, the frames for these new satellites, deep space probes, or other kinds of equipment could be fabricated from iron and copper and aluminum and so forth on orbit, and have the more intricate components still produced on Earth, packed into cases, shipped up to some place like the International Space Station or something like that, and installed on these frames, and then you release that satellite or that probe or that piece of equipment to where it needs to go. This could afford us a new avenue for reducing the cost of shipping things to space, cleaning up orbital debris, and creating manned spaceflight employment. Expanding manned spaceflight employment can have other spin-off benefits as well. This is Darren Marchant with American Nomad News. Please like, subscribe, comment, and please share this with someone from a different continent than the United States, than North America. I look forward to your comments on this idea on YouTube comment section. Thank you very much. Godspeed.